A chemist analyses a naturally occurring aromatic compound. Part A. The percentage composition and mass spectrum of the compound are shown below. Percentage composition by mass. C 70.58%, H 5.92%, O 23.50%. Determine the molecular formula of the compound and show your working. Firstly, what we need to do when answering this question is work out the empirical formula of the compound. We do this by taking the percentage compositions by mass of C, H and O. So for carbon, we have 70.58% and we divide it by the relative formula mass of carbon, hydrogen or oxygen. So for carbon, that's dividing it by 12. That gives us 5.88. Then for hydrogen, we have 5.92 divided by 1, and that gives us 5.92. For oxygen, we have 23.50 dividing by 16 gives us 1.46875. The next step in working out empirical formula is divide by the smallest value. This would be 1.46875. So dividing oxygen by that gives us 1. Dividing hydrogen by 1.46875 gives us 4. And dividing carbon by 1.46875 also gives us 4. So that makes the empirical formula C4H4O. We then look at the mass spectrum. The rightmost peak, or furthest to the right peak, that gives us the relative formula mass of the entire compound. So if we read off this peak here, that's at 136. So that means that the relative formula mass of the entire compound is 136. So if we look at the relative formula mass of the compound we've worked out, that would be 12 times 4 plus 16, which gives us 68. So then we need to multiply by 2 to get 136, because 136 is 68 multiplied by 2, so that would make the whole relative formula mass of the compound correct. So that makes our molecular formula C8H8O2. In this question, you get a mark for working out the empirical formula, a mark for multiplying or reading from the mass spectrum, and a mark for getting your molecular formula correct. B. Qualitative tests are carried out on the aromatic compound. The results are shown below. Determine the functional groups in the compound and explain your reasoning. If we start on the right, Tollens reagent is a test for an aldehyde. Here I'm just drawing the general structure of an aldehyde. If there was an aldehyde present, Tollens reagent would react with the aldehyde group and form a silver mirror. But there's no observable change, so there's no aldehyde group. 2,4-DMP is a test for a carbonyl group. And the positive test for a carbonyl group is an orange precipitate, which the person has observed. Therefore, there is a carbonyl group. Sodium carbonate is a test for a carboxylic acid. Here I'm drawing the general structure of a carboxylic acid. If there was a carboxylic acid present, the observation would be an effervescing or fizzing. But there's no observable change, so there's no carboxylic acid. The acidity of pH 5, well, that's pretty weak, so it's a weak acid. Therefore, our functional groups are a ketone because there is a CH or carbonyl group, but no carboxylic acid or aldehyde. So it's got to be a ketone. So ketone. And then a phenol. Phenol, because it's a weak acid, and also linking to the question, well, it says that it's an aromatic compound, and phenols are aromatic compounds. So to get this 3 marks for this question, you need to have the correct functional groups, ketone and phenol, and your explanation needs to suggest that there's no carboxylic acid, no aldehyde group, so it must be a ketone, and that the compound is a weak acid, so the phenol group is your other functional group, and that's how you get 3 marks. C. The carbon-13 NMR spectrum of the compound is shown below. Using the spectrum and the results from A and B, determine the structure of the compound and explain your reasoning. If we start on the right of the spectra, this peak for the rightmost side, if we compare the values to the data sheet, that's a carbon-carbon bond peak. So in our reasoning, peak between, we write between because for spectra we say a range, you won't have exact values, between 20 and 30 ppm is a carbon-carbon peak. Then, moving left, we've got these 4 peaks in the middle of the spectrum. Well, they show or signify an aromatic. So, peaks between, again stating a range, this time 110 and 160 ppm are for aromatic compound, which we know is going to be a phenol. Finally, our peak on the leftmost side, so peak between 190 and 200 ppm is for carbonyl group. Then for our structure, we can start by drawing a phenol because we know that that's going to be in our compound. Here, drawn a phenol, and then we need to draw our ketone. Here, I've drawn our ketone. Now we need to do a bit of checking. First, we need to check that we've got 6 carbon environments. So if we number them, 1, 2, now here on the benzene ring, they would be symmetrical. So 1, 2, 3, 4 around because they're the same environments if we drew a line of symmetry. Then we've got 5, 6. If we compare 5 and 6, well, 5 would be for our carbonyl and 6 would be for our carbon-carbon bond. Then if we check the molecular formula, we can check we've got 1 carbon, 2, 3, 4, 5, 6, 7, 8. So we've got 8 carbons. Have we got 2 oxygens? Well, that's easy to check. We've definitely got that. Then for the hydrogens, a bit more thinking. We've got 1 there. We would have 1 hydrogen on each benzene point or each phenol point. And then we would have 3 towards the end because a carbon at the end would have to have 4 bonds. So we would have 3 hydrogens. So if we count these all up, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 hydrogens. For this question, you get 2 marks for your reasoning and you get 1 mark for the correct structure.